Let's take a look at this MyMathLab problem. You want to have a $50,000 college fund in 16 years. How much will you have to deposit now under this scenario below? Assume that you make no deposits into the account after the initial deposit, and the APR is 5% compounded daily. So let's start by writing down the facts. So let's start with our formula. The formula is that the final amount is equal to the starting amount of P, the principal, times 1 plus the rate, which is I'll just say rate over the number of times in a year it will be compounded, in this case daily, so 365, raised to that m value times t. Well, let's go ahead and fill in the amounts. The final amount we want to have is $50,000, so put 50,000. We do not know the starting amount, that's the question, so we put P. And this is 1 plus a rate of 0.05 over 365, because M represents the number of days in a year. And then we raise this to 365 times the time, which is 16 years. So what we need to do is we need to resolve what this is and then solve for P. So let's work this out. To do this, what we want to do is divide both sides by this piece right here, this entire piece. As a matter of fact, I'll put it in a bracket. There we go. So that we want to divide both sides by that. So let's go ahead, and when we do that, we get what P is equal to. P, increase the thickness there, okay. P is equal to 50,000 divided by the bottom piece, which is 1 plus the ratio 0.05 over 365. And this entire thing is raised to the 365 times 16. So let's write how we would enter this into our calculator. In our calculator, we would start by entering the 50,000 with no comma, divided by, and what I'm going to want to do here is I want to imagine that I have a bracket in the denominator, sort of grouping it all together, okay? And that's what this is going to be. This is my bracket in the denominator. This is my left-hand bracket. I haven't put the right-hand bracket in to match it yet. And then the next thing I want to do is I want to put in the binomial. So that's it's called the binomial, two terms added together, because it's added 1 plus this fraction. So I would say 1 plus, and I'm going to put a parenthesis around the fraction sort of to group it together, 0.05 divided by 365, and I'm going to close that parenthesis, okay? And by closing that parenthesis, these two parentheses go together. This represents my fraction. And then I need to close this parenthesis, or rather, let's see, I want to put another parenthesis in there. Let's put one here, okay, and here. So by doing that, what I've just done is I have grouped the 1 plus the fraction as one entity. And this whole thing is going to be raised to a degree. So we're going to say raise this up arrow to a degree, and the degree is going to be, and I'm going to put a left parenthesis, and the entire degree is going to go in there, and it's going to be 0.0, oh, excuse me, let's see if I can fix that. it's going to be 365 times 16, and this is what the times looks like on the calculator, and I'm going to close this, okay? And so what I've done here is that this represents the entire exponent. We have in parentheses the entire binomial, where you have 1 plus a fraction. This actually is what we consider a binomial, two terms, sort of a binomial. It's the sum of two entities, I should say. This is not really a term. So it's a 1 plus a fraction. So I've grouped them together in parentheses, and then I'm raising it to an exponent that's grouped in parentheses. And then this last parenthesis, I have to close it. So let me close that. And let's just see how they match up. These two parentheses, and I'll put them up here, match up. They close our exponent. These two parentheses close our fraction, so they're kind of evaluated separately. These two parentheses create the sum of 1 plus the fraction. And then these two parentheses say that everything that's in here becomes the denominator to this 5,000. And this is what you would enter in the calculator to get the principal.